So next up, we are going to discuss least common multiple. So to think through least common multiple, let's consider this situation. So hot dogs are usually sold 10 to a package, but hot dog buns are usually sold 8 to a package. What is the least number of packages of each you must buy so that there's an equal number of hot dogs and buns? So the number of hot dogs has to be a multiple of 10, and the number of buns is a multiple of 8. The number of hot dogs matches the number of buns whenever 10 and 8 have a multiple in common. 10 and 8 are going to have a multiple in common at 40, 80, 120, and continuing on, but the least of these multiples is 40. So we're going to have to buy the same number of hot dogs and hot dog buns by buying 4 packages of hot dogs and 5 packages of buns, because 4 times 10 will give us 40 hot dogs, and 5 times 8 will give us 40 buns. So this is the least common multiple. 40 would be the least common multiple between 10 and 8. The least common multiple of two non-zero whole numbers a and b is the least or smallest non-zero whole number that is simultaneously a multiple of a and a multiple of b. Just like with greatest common divisor, we have a few different methods for finding the least common multiple. So if we wanted to find the least common multiple of 3 and 4 using what's called the number line method, we would start at 0 on our number line and take increments of 3 and increments of 4 up on our number line until we meet at the same number. So beginning at 0, the arrows don't coincide until the point 12 on the number line. So 12 is the least common multiple of 3 and 4. We could also use colored rods, very similar to the number line method, by taking a 3 rod and a 4 rod and seeing if we build trains of 3 rods and 4 rods until they're the same length, the least common multiple is going to be the common length of that train. So it took 3 4 rods and 4 3 rods to match up at the same length, and we get a length of 12. Just like with the greatest common divisor, there's also an intersection of sets method for the least common multiple. But in this case, we're going to list all of the positive multiples of the two integers. So we're listing multiples rather than divisors. Then we're going to find the set of all of the common multiples, and finally pick the smallest element in that set. So to find the least common multiple of 8 and 12, we're going to list out the set of positive multiples of 8 and call it M8, and list out the positive multiples of 12, call it M12, and then we look for those multiples that they share in common. So I see that M8 is going to have 24, and so is M12. I see that 48 is in both sets. I see that 72 is in both sets, and these are actually all multiples of 24. So the intersection of M8 and M12 is 24, 48, 72, and the least number in that set of common positive multiples is 24. So the least common multiple of those two numbers is 24. We can also use the prime factorization of two non-zero whole numbers or more to find the least common multiple. So we're going to first find the prime factorization of each number, and then take each of the primes that are factors of either of the given numbers, and then the least common multiple is the product of all those primes, each raised to the greatest power of the prime that occurs in either prime factorization. So let's look at an example using the prime factorization method for 2,520 and 10,530. So we first need to find the prime factorization of each of these numbers. So let's find the prime factorization of 2,520. You can use a tree diagram to do this. So I know that this is going to be divisible by 10 because it ends in a 0. So I can divide 2,520 by 10, and I get 252. 10 is divisible by 2 and 5. And 252, I know that's going to be divisible by 2 because it ends in an even number. So 252 divided by 2 gives me 126. So I can split that into 2 and 126. 126 is also divisible by 2 because it's even. So I have 2 and 63. 63 is divisible by 3 because 6 plus 3 is 9, and 9 is divisible by 3. It's 3 times 21, and 21 is 3 times 7. So 2,520 is, if we find all those prime factors, I have 2 3 times. So I have 2 cubed, 2 3s. So that gives me 3 squared. Then I have my 1 5. And I have 1 7. Okay, now I need to find the prime factorization of 10,530. Again, I know that's divisible by 10, so 10 and 1,053. 1,053 is divisible by 3 because 1 plus 5 plus 3 is 9, which is divisible by 3. So it's 3 and 351. And 10 is 2 and 5. 351 is also divisible by 3. 3 and 117. 117 is divisible by 3. It's 3 and 39. 39 is divisible by 3. It's 3 and 13. And now all of the branches of our trees end in prime numbers. So I've got 1 2, 4 3s, 1 5, and 1 13. So 10,530 is 2 times 3 to the 4th power times 5 times 13. So when I look for the least common multiple of these two values, I'm going to take all of the prime factors of both numbers. So I have 2, 3, 5, 7, and 13 because I have 2, 3, 5, and 7 in 2,520, and I have 2, 3, 5, 13 in 10,530. And now I'm going to take the greatest power that each of those are raised to. So I have 2 to the 3rd power, so I'm going to have the 3rd power on 2. I have 3 to the 4th power, that's the larger exponent. 5 is in both cases secretly raised to a 1, so it's just going to be to the 1st power. 7 is secretly raised to a 1, and 13 is secretly raised to a 1. So those have hidden exponents of 1. And my final least common multiple will be 2 cubed times 3 to the 4th times 5 times 7 times 13, which is 294,840. Here's that work typed out for us. All right, the last thing we're going to discuss is what's called the GCD LCM product method. So for any two natural numbers, A and B, the greatest common divisor of those two numbers times the least common multiple of those two numbers is equal to the product of A and B itself. So I can use this fact to find the least common multiple of 731 and 952. So I know that fact, remember, is GCD of 731, 952 times LCM of 731, 952 is going to equal 731 times 952. So if I can find the greatest common divisor and the product of those two numbers, then I can solve for the LCM. So let's find that greatest common divisor of those two numbers. We can use the prime factorization method, 731. 731 is actually a kind of tricky number to find the prime factorization of, but what we would do is we would just think through our first few primes. So 731 is not divisible by 2, it's not divisible by 3, it's not divisible by 5, it's not divisible by 7. You could just try that in your calculator and you'd see that it's not. It's not divisible by 11 or 13, but it is divisible by 17. So the prime factorization of 731, I'd start by dividing by 17, and I'd see 731 divided by 17 is 43, and 43 is actually prime. So the entire prime factorization is just 17 times 43. And then for 952, I can first divide by 2, because I know that that number is even. So it's 2 and 476. I'll divide by 2 again. 2 and 238. Divide by 2 again is 119. 119 is another one of those tricky numbers that we would have to think through the first few of our primes. But you should figure out that 119 is divisible by 7. And when you divide it by 7, you get 17. And so now all of our factors are prime. I have 2 to the third power times 7 times 17. So I look for the greatest common divisor of 731 and 952. I take the factors that they have in common, which is actually only 17, and I'll take the least power that I see, and they both have a hidden exponent of 1, so it's just 17. So I know using this fact, I'll take 17 times the LCM of 731, 952. And that's going to equal 731 times 952. So I multiply 731 times 952, and I get 695,912. So I have 17 times LCM of those two numbers. And then I divide both sides by 17. And I get that the LCM is 40,936.